In this video, we have the integral of x over x squared plus 4x plus 8 to evaluate. And this is a rational expression here for the integrand. It's in proper form. The degree of the numerator is less than the degree of the denominator. But we can't factor the denominator over real numbers. So let's see if we can get a U-substitution to work. Now, on some occasions, you might let the U equal to what's in the denominator. And if the derivative of that gives you an expression of x that's in the numerator, that could work. Now if we had a 2x plus 4 up here, it would work. But we don't. So let's see, let's rewrite this. X plus 2 squared will give me the x squared. Double this product will give me the 4x. And then 2 squared will give me a 4. We have an 8 here. So to make up for that, I have to add a 4 here. So all I've done is rewritten the denominator. Still the same thing. X squared plus 2, or x plus 2 squared, does give me x squared plus 4x plus 4. I want an 8, so I just put the 8 right here. So now this is the same thing as what I have there. Now I can let u equal to x plus 2. Then the du would be the derivative of x plus 2, which is 1. Or 1 dx, I just put dx here. So this would equal to, still got the x here, and then the dx is be the same thing as du, and the denominator got x plus 2 squared, x plus 2 is u, so this would be u squared here, and I got plus 4. We can't have an x though, to complete this transformation. It has to be all variables involving u. So from this one right here, I can solve this for x. So x would equal to u minus 2. So now we have this integral. The x is replaced by u minus 2. Still got the u squared plus 4 in the denominator. Again, I have a rational expression in terms of u, but the u squared plus 4 doesn't factor over real numbers. So let's do this. Let's break this up into two integrals. So this will be u, or u squared plus 4, du. And then I've got minus the integral of 2 over u squared plus 4. And this is du. This one can easily be integrated now. The first one here, because the derivative of u squared plus 4 with respect to u is 2u. And I've got a u here. Remember, the constants don't really affect this as far as integration goes, because you could just factor those out. So if I were to use a u-substitution here, for the first one, I'd have to change the variable. So u1, I let u1 equal to this, u squared plus 4, and then differentiate that, and I'd get 2u, u, du, and then I'd have a factor 1/2 out here. So this is just going to equal to, without having to go through all those steps, this is just be the natural log of absolute u squared plus 4. And I'd have the 1/2 over here. Let's check it. Take the derivative of this. Constants out here would be u squared plus 4 in the denominator, which is right there. And the derivative of the numerator with respect to u is 2u, and you got the 1/2, that cancels the 2, and it gives me the same thing I have. So double check there. And then for the next one, this is just the integral that leads to the result of arctangent. If you have the integral du over u squared plus a squared, done this before. In fact, we might have done it in the last video. It's 1 over a arctan of u over a. And of course you have the constant of integration. In our case, we have 4 squared is a squared, so a is 2. So this would be 2 here, this would be 2 out in front. But remember, I have this 2 already. So 2 divided by 2 will give me 1. So this is just going to give me the arc tangent. You can also use tangent inverse there of u over a. So this would be u. In our case, a is 2. And it's plus the constant of integration. Now all you have to do is go back to the original variable. So when I go up here, this will be equal to 1/2. And remember, this u squared plus 4 is that denominator right there. So this is just going to be x squared plus 4x plus 8. And that's minus arctangent of u, but in our case u is x plus 2, over the a, of course in our case this is 2, plus the constant of integration. So this is your final answer. 1/2 ln of the absolute value of x squared plus 4x plus 8 minus arctangent of x plus 2 over 2 plus the constant of integration. Thanks for watching. We'll see you next time.